Patching. That's what we're talking about today. Now, this usually involves some engineer who has to give up his early morning, work late at night, maybe on a Friday or even on the weekend to minimize the impact that patching causes. But what if your servers could patch themselves autonomously? No calling out sick 24/7. So that's the question that I've been considering with my own hosted environments. So I built an AI patching agent as part of a broader agentic IT department to test that theory. And it patched real infrastructure end to end. I'm going to show you exactly how it works, the architecture behind it, and the lessons that I learned when things went wrong. And they do go wrong. All right, let's dive into this agentic IT organization that I'm experimenting with. You're looking at a standard enterprise IT structure. Nothing special there. People have been occupying and doing these roles for decades. But here's where it gets interesting. I'm injecting some agentic skills or AI agents into these roles, which effectively augments and provides these roles with superpowers. This isn't about replacing people. It's about turning IT professionals into strategic powerhouses, effectively moving them higher up the stack. So the AI handles the repetitive operational grunt work, and engineers and people do what they do best, right? Which is solve complex problems, architect the future, driving innovation. Think about it. When was the last time your sysadmin got excited about patching servers at midnight? Let me answer for you. Never. But ask them to design a resilient architecture that possibly handles Black Friday traffic? Yes. Challenge accepted. Now you've got their attention. All right, so let's meet this agentic IT team and the skill sets that I'm looking to add. And these are not like chatbots, they're specialized AI agents that can reason, make decisions, and solve problems in their specific domains. At the top here, you have the AI IT manager. He's basically the conductor of this entire digital orchestra here. He never sleeps, coordinates everything, handles escalations, talks to management, no office politics. You have your sysadmin agent over here. He's managing your entire server fleet, doing all of the patching for your infrastructure. And in fact, these are some of the skills that we're going to demo today, the inventory patching and ticket updates. You have your knock agent. He's basically like your tireless sentinel monitoring your infrastructure 24/7, doesn't take any coffee breaks. 3 a.m. he's determining if that alert is critical or not. You'll have your network agent. He's like your network whisperer, looking for any anomalies in your environment, and he's able to determine if it's a network issue or it's not. It's usually a problem. You have your security agent over here. He's like your digital guardian, handling like your compliance and auditing. Any new 0-day CVEs, he's going to let you know, or she. You have your DevOps agent. He's going to have your SLA and observability stuff going on, managing your CI/CD pipelines and whatever software lifecycle you have him managing. Then you have your help desk agent over here. He's going to be doing your end user frontline triaging, intelligent routing, gathering any context that's needed. So let's get into the code. Okay, when looking at the code, keep this overall flow in mind. This is the LangGraph flow that orchestrates everything. Each node here in the flow has a specific job, and they communicate from node to node with a shared state. So the output of one node becomes the input of another. It starts here with the inventory node. I tell this inventory agent in plain English something like patch all servers in the infrastructure category. And it uses the tools here in this get server details, get server by category. These tools are registered to this agent, and it uses that to determine how to handle that natural language input. So in this case, it's going to query my Django database, which looks like this here. So you have database, IP, host names, category, like infrastructure here. There's no hard-coded IPs in the code. It's strictly making that decision based on natural language. Next, we have this Jira create agent, and this agent spins up a ticket automatically. It pulls the server information, the details from this inventory agent, and adds it to the ticket. And it also retains the ticket ID and adds that to the state that's passed to the other nodes. So with this node, you'll have traceability of your entire patch cycle in your system of record. Then the flow goes to the patch agent. And this is where really all of the magic happens for this demo, right? This patch agent has access to these tools, patch server and reboot server. And it uses the large language model to determine what to do with the request. Should it reboot? Should it patch? In my demo, I had to get a little bit more deterministic about this patch agent as my experimentation unfolded. But this goes out and runs commands on the server, depending on the operating system. And that could be update the server or reboot the server. After that activity has completed for all servers, it passes that information to this node here, the LLM summarize node, which then goes and summarizes not only the conversation to the large language models to OpenAI, but also the output of the server logs from the patching activity. And it creates a summary of that activity and passes it to the Jira update node. This update node does not have an LLM. It's strictly deterministic and just sending an update on the original ticket that was created by the inventory node. It'll create a comment. That's what the code is going to show you as we step through it. Okay, so keeping the reference flow diagram that we just saw, let's look into the code. We'll start with the main agent structure here that does the coordinating. And I'm using LangGraph. So you'll see LangGraph here to define a workflow as a state graph. So I'm using LangGraph here, and I'm actually using OpenAI for my large language model. Going down to kind of bridge what you saw. So here I'm creating a state graph, which is what these nodes are in this flow. And I'm instantiating it with a supervisor state. So I'm passing a state object to it. So quickly, that is here. This object has the messages. This is representative of the messages that are sent back and forth to the large language model. I also talked about the ticket ID that gets sent to all nodes from the Jira create agent all the way down to the Jira update agent, as well as the server activity log. So that's how each node maintains the state as it goes through the workflow. So as you can see here, I'm creating a node and pointing it to a function, really. So each one of these nodes is effectively a function that takes in a state, performs some activity, and then updates the state and passes it along. So down here, here we create the nodes. And here we define the actual flow, right? So where it starts and where it ends. You have the entry point and the finish point here. And in between, you have nodes and edges here. As you can see here, the inventory agent is connected to the Jira create agent, and then the Jira create agent is connected to the patch agent. If we look at the original diagram here, these are the edges. These lines are what LangGraph uses as edges. So the inventory agent is connected to the Jira create agent using this edge here. That's how the flow is actually created. Let's take a look at the tools, right? We spoke about over here that these agents have access to these tools over here. So let's take a look at the inventory tool here. And here, these are two tools defined by using LangChain's tool library. And basically, I have two tools, get server details and get server by category. This is the one that I'll use in this demo. So it's essentially takes a category and returns some kind of string. All of the tools have to have this kind of description. This gets sent to the model, whether it be Gemini or OpenAI, and gives it some context and some understanding of what this tool actually does. In this case, I'm taking whatever category is passed into this get server by category function tool, and I'm querying my Django database, which I previously showed, and returning some objects. Here you'll see the update tool as well as the create tool. Again, you have your description and whatever is actually being done here. You have your patch tool. This is what's actually doing the patching. See, we have a very descriptive description of the tool here. We're passing in a host name and a method. This method by default is apt. Most of my servers are either Ubuntu or Debian right now. And so these are the commands that get triggered. So you have your SSH directly to the host name that's passed in and effectively running this command. There's definitely more sophisticated ways to do this. But for my experiment, I'm just using a sub-process to actually perform that SSH function. So that's how the actual servers get patched. A simple command. And also the reboot tool here, basically SSH into that host name and run a reboot command. Going back to the original script here, you can see that I'm importing all of those various tools that I just described here, and I'm putting some of them in a list that I can then pass to the agents. So here I'm actually defining the agents, and I'm using LangGraph's built-in agents. So this create React agent is a built-in library that LangGraph provides for creating agents. So I'm passing in my model. As I said, I'm using OpenAI, using GPT-4, and my temperature is 0, which is actually important so that your tools are interpreted literally, and that the model doesn't try to kind of come up with its own responses of what those tools does in a creative way. And I also pass in these tools here. So this inventory agent has access and it registers these inventory tools, which are these here. So that's overall how this thing works. Down here is where this supervisor graph actually gets invoked. So this is where the natural language prompt that I send in actually kicks off the entire flow. In this case, I am sending both a system message to assist with enabling the model to understand exactly what I wanted to do here. And my message is being sent from the command line, and that's my human message that's being sent. So let's see an example of this actually kicking off and performing patching. All right, enough theory. Let me show you this system working on real infrastructure. I'll show a happy path example, and then we'll really test things out, shake it up a little bit with some unpatched servers, change up the category, and let's see if we can get a dangerous demo. So I'm on the command line here, and I have my supervisor agent Python file, and I'm going to send it this natural language command. So I'm saying patch, then reboot all servers in the infrastructure category. So I'll go ahead and kick that off. If you remember, in the infrastructure category, I have these two servers, so that's what I'm expecting here. If I go ahead in the OpenAI logs here, I should see some activity around this time. I can see right here, I'm getting my servers by category. There's some activity here. Oh, I saw some windows get closed here, which is expected on a reboot. And this one looks like it's being rebooted as well. So let's see what happened here. I should see a new ticket come in here. So let's refresh. Maybe, there we go. 62 was the new ticket. And you'll see that it actually creates this ticket with this description. It says, hey, the following servers in the infrastructure category will be patched and rebooted. Gave 2 servers. And in the comments here, the Jira update node gave a summary. It says, hey, I patched and rebooted this comms01 server and also this monitoring server here, and gave an overall summary down here. It says all patches and reboots were successful on both servers. No failures or warnings were reported during the process. So that's kind of expected behavior here. I'm going to go ahead and switch this up a little bit and see if I can perhaps get a failure scenario. Let's look at these 2 servers here, this web proxy 01 and 02. And this, so I'll switch this up to the web category. Now, this may take a while, so I may have to stop the recording because they haven't been patched. Maybe it fails. I saw in a previous failure where I had a SSH timeout because the patching took so long. So we'll see it. See what happens. Kick that off and take a look at the logs real quick. You know what? I'll go ahead and log into those servers right now. And you can see it right here. It's already looking for the web servers here. Ah, failure. No specific host names were mentioned in the logs. Fail. That's a fail. Okay, so looking at this failure, one thing that stands out to me, a couple things actually. Let's see, this message right here, I can trace this back into code to where this is being executed and this message is being shown. So that's one thing to see. The other thing to see is that the assistant didn't actually provide the IP addresses here. So the expectation is for the assistant to, so the tool works, right? The get server by category tool works because it extracted the right information. But the assistant in its summary did not put in the IP address here. So if I kind of go back to an example of the infrastructure, it pulled the same servers from the tool, but the assistant used the host name and the associated IP. Those are 2 things that I can actually look at. This is where sometimes you have to kind of massage what you say to the LLM. I'm wondering, let's, for giggles, kick it off again and see what happens. The other thing that I noticed was that in my sudoers file that controls what commands can be ran on this server, I didn't have anything set up yet for these 2 servers because I've never ran through this process on these servers. So we have a failure again. So I'm going to continue to kind of dig into this failure. So just restarting didn't work. We're going to look a little bit deeper into this. So that's in the patch node here, that message here, right here. So there's no servers being passed into this patch node here. So either, well, I know that because the Jira agent, the LLM, didn't actually send it. So I have to figure out a way to get the LLM to like this web category. There's something about this web category that it's not really jiving with. So let's see if we can figure that out. So I suspect this is literally just like an LLM issue. Maybe if I rephrase something in the LLM, it will magically work. So go back to my supervisor agent. Let's add something here. Always list out servers being patched with ease. This is where structured output really makes a difference. Right now, I'm not using structured output, so I'm at the mercy of whatever the assistant actually wants to give me. Let's kick this off again. Let's see what happens. We did turn this into a... All right, so that we expect. Ah, look. Looks like it passed the IP this time. So getting closer. It got the IP. So we've got tickets being created, but this is still not what I expect to happen. But we're getting closer. I see this weird thing here, server and server. These are kinds of things that happen when you're actually troubleshooting this. When you're not using structured output, you get things like this. As you can tell, that was definitely something with the large language model in the way that it was actually interpreting things, but it worked perfectly fine with the word infrastructure, just not the word web. So temperamental. Okay, so just kind of tweaking the prompt that I'm sending to the LLM, the human aspect, the human part of the assistant. So I just put here, list out the servers being patched with IPs. Let us see. Am I getting any logs? No. And we will go again. See what it does. But it's taking longer than I actually expect it to take. So I wonder if it's actually patching it. No, not that one. Let's see on O1. Nope. Not seeing any patching activity, but it's doing something. Let's see, did it create any logs? Yeah, it's actually... operation timed out going to this particular node, but it's definitely getting the right IP on this, so I'll have to see why is it timing out. This has happened before, so maybe I'll look at extending that. Okay, so we're getting the right IPs. It's executing the way that I want it to execute now, and I should see another log here. Oh, it literally just timed out. I am going to... it says this sudo reboot timed out. So which one is this? That was 01. I don't see it running an apt update though. Should have ran and seen if there was actually any updates. I thought there was. 82 packages can be upgraded, so it should have attempted to at least. But this may be a case where it takes a long time, way beyond the default timeout. So I'm going to go ahead and update the timeout on SSH. Tools. You know what? Let's get rid of this log. Yep. In my patch tool, I'm going to increase this some really high number and try it. If that fails, I'll try something else. So kick that off again. Let's see what happens. Let's see how it's looking. Okay, so that should do something. Now to see if I think it goes to this one first anyway. That's where what you need some additional logging. I kind of wanted the feedback to be kind of quiet, so, but in this case, I need more feedback. I don't see anything in the logs yet. Oh, okay. Okay, so I still didn't, it's still not going to this server. Why? All right. Ha! Ah! Yes, 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 yes. Okay, I get it. I'm using an intermediary jump server that only recognizes the host name, not the IP via SSH. Or I'm getting back the IP, but I need to get the host name as the SSH because this network is not reachable directly from this host. So I'm using a jump server. So let me see if I can correct that by just changing the SSH configuration. So that's this guy right here. Let's see. May have to do this on the jump server as well. And we'll just do the O2 server just in case this works. And I don't have to come back here and do it. All right, let us see. So then I'll go to this server here. And this guy should be able to reach that IP. We'll try it. Yeah. All right, so this should probably work. Okay, so let's see. Let's SSH from here to this guy. If this works, then that solved the problem. Yeah. Cool. Let me send my key up there. Okay, yeah. It does already exist. All right, so, let me do that so it doesn't flake out. And let's kick this sucker off again. Some space there. Go. See what happens. So go back here. Logs. All right. My IPs. Oh, yeah. Okay, so it literally just changed that. Ticket 68, still running. Let's see. No app there. So, I don't know. Maybe, oh, this one first. Ah, haha. It's running. It's starting to patch. So, I see that it's running apt upgrade. So, this server is getting patched first, and then this one will go. So, this looks to be where it's going to actually complete. And I got my ticket number 68. Oh, where's my ticket? There it is. All right, so those are the IPs there. And we know that this is running. It might take some time. Yeah. But I did increase the timeout value on my SSH connection. So we'll see how that works. I'm going to stop the recording of the video and I'll start it back up when it's done. Oh, okay. So this guy was rebooted. So that looks like it's starting to go. Let's see if this guy started patching. Yes, indeed. So the O2 server started patching now. Should probably take around the same time, since I suspect they had the same number of patches to be patched. So maybe a good 2-3 minutes for the server to patch. All right. Looks like this one was finished patching and rebooted as well. And yep, let's refresh our ticket. We should see a comment down here. Yep. It says this one had a problem. Reboot skipped. Clearly it actually it patched it. Let's see. All patched. So you can tell that's an edge case, erroneous. So I'd be interested to see if I go ahead and run this one more time. What does it come back up with? What happens during this happy path? Since it already has all the packages. That was quick for that one. There's nothing to patch. And that was quick for that one because there's nothing left to patch too. So let's see. Should be a 69 ticket here. Yeah. That server, yep. Patched. Connection issues. This is weird. I'll have to look at this one, but you can see the summary that is provided here. Out of the two servers, it says patching and reboot was successful on Proxy 01. Proxy 02 encountered connection issues during the patching process. I'll probably go ahead and throw this into ChatGPT and see what it says. Maybe it's something specific to that server. But you got a happy path demo and a dangerous, very dangerous demo. Okay, let's wrap this up with some lessons learned. The AI will confidently lie to you. You've got to have checks to validate that the expected action was taken, even if things show as successful. In my case, the AI fabricated host names when confused and reported successful patches that never happened. So trust, but verify, always. Consider guardrails. Last thing you want is your AI hallucinating a destructive command like rm-rf and wiping your entire production server. I implemented sudoers with limited command scope to restrict what actions the AI could actually execute. So expect to spend significant time in QA testing of edge cases and failure scenarios, because the LLMs will find creative ways to break things when the environment isn't ideal. When AI meets Murphy's Law, anything that can go wrong will go wrong. This is already a lesson that we know in IT. You saw my happy path, and then you saw reality. Production will surface those edge cases. For example, when my agent hit a full disk during patching, it initially failed because the LLM only had limited server output data. I had to expand the LLM context with more server details and guide it towards actionable steps. Maintain model consistency between testing and production environments. Even minor model changes can introduce breaking behavioral differences. Case in point, when I switched from GPT-4 to GPT 3.5 for cost optimization, my agent began duplicating every Jira update despite having identical prompts and code. Reverting to GPT-4 immediately resolved the issue. Each model is unique. It has unique reasoning patterns and the output tendencies that affect system behavior. Prompt phrasing is just as important as code. The LLM does not do well with conditional, multi-step, or ambiguous phrasing. When I went from patching only to patching and rebooting, this phrase that I passed to the LLM, if patching successful, then reboot, caused the agent to default to generic reasoning instead of invoking my registered tools. Don't build fat agents. That's what I call them. The more tasks you pile onto one agent, the more ambiguous its decision-making becomes, leading to unpredictable outcomes that can be catastrophic in production environments. Instead, design focused, specialized agents that master specific functions. Think microservices, but for AI. Structured output is your friend. Use structured output. As my experiment evolved, not explicitly using structured output caused wasted cycles once the user prompt changed just slightly. Save money using local LLM for testing and internal deployment. If you're continually adding complete state, so the information that's going back and forth between you and the large language model assistant, and contexts such as server logs to the large language model, your token usage grows exponentially at a cost. Leverage ways to reduce context through summarization and token limitations. Version everything, prompts, models, and configs. Treat your agent system like code. When something breaks, and it will, you need to know exactly what changed. Build observability from day one. Log everything. What the agent decided, why it decided it, and what actually happened. You'll need this data for debugging and improvement. All in all, building this out has been both exciting and humbling. Every failure, every bug taught me something valuable. I'll continue to refine my approach as I honestly believe we're just scratching the surface and the potential is literally massive. But so is the responsibility to build them right. Keep building, keep learning, and I'll see you next time.